Hello everybody and welcome to my channel. Today's project it's basically a manufacturer's rated 100 watt per channel amplifier. It's a mono block, in other words you need two modules for a stereo amplifier. Its main claim to fame, I guess, is its ridiculously low price. If I tell you I paid $8.64 New Zealand dollars for each module, that is plus tax, but including postage. How they make it for this kind of money, I have no idea. And I'm going to test it later on and tell you what I think of it. I should tell you straight away is one of the reasons that it is so low cost is the fact that the output transistors are pulls. That's not a new manufacturer. That means it's been salvaged from other equipment. Now, bearing in mind they are Toshiba transistors, if they were brand new transistors, you couldn't, well, the price would be double, at least double, because the power transistors are the things that cost the money in any amplifier. When you look at this, you can see they've actually been pulled. They've been cut off and new extension legs have been, or terminals I guess you'd call them, have been added. And the transistors themselves do look like they've been in the wars a little bit. If you get close up, as you'll see in these pictures, they are dusty and they've got scratches on them. And clearly they've been all piled up in a big skip somewhere, and someone's gone along and thought, ooh, can make some money here. And they cut them out, and I would like to say tested, but I wouldn't let that put you off the amplifier, because at the end of the day it's not like a valve that if you buy one second hand you don't know if the emission's on the way out or how good it is or whatever. By and large a transistor tends to either work or it doesn't. I connected all this up with a little trepidation, thinking, is it going to go bang? But I started it off on my switch mode, current limited supply. These are basically some of the observations I have made so far. This is the little board in question, and the things that I would comment on straight away, there are no preset pots on the board at all. So you can't adjust any DC offset, you can't adjust the center point, and you can't adjust the quiescent current. It actually says in the instructions suitable for, I can't remember what the lower voltage, I think it's 25. Now you need a plus and a minus power supply to run this amplifier. So in other words, 25, 0, 25. DC, and it also says you can use up to 45 volts. All the ratings and figures I will give you are based on a plus and minus 35 volt supply. The 100 watt rating may well be true into 4 ohms, but it's certainly not true into 8 ohms. We'll measure it presently, but just the mathematics tells me it is not going to deliver 100 watts into 8 ohms. As a rule of thumb, you would say a plus and minus 50 volt supply would be required for 100 watts, approximately, into 8 ohms, and possibly double that power to 200 watts into a 4 ohm load. I would not recommend using anything other than 35 volts. If the manufacturer of these boards says don't use anything more, but you can do, to me that's asking for trouble. And the reason I would suggest that that is the best voltage is the drivers are here and they are basically just standard, they're quite high current transistors, but there's no heat sinking on them at all, and as they are the drivers, they will get hot. And particularly if it was a 100-watt amplifier, you would need probably a more substantial driver transistor than there are on here, and they would certainly need to be on a heatsink, which they ain't. Here I have one of the modules already mounted on a substantial heatsink. I put it on this particular heatsink is because I happen to have it and the holes just happen to line up. Now, one thing you're going to need is mica or some sort of washer to isolate the transistors, but those parts are not supplied with the kit, so you've got to go and find those. Now I have this all ready to go. Right, we're going to power up. I have to press these both at the same time so we get the voltage coming out at the same time. I've got current limited, and you can see I have 35 volts coming out of each. I've now switched the load off it, so so that's 35 volts, and you can see our current draw and the wattage that it's being drawn so far. When you turn the voltage down, the current obviously drops, and normally you'd reach for the potentiometer and adjust the quiescent current, but as there is no adjustment, this is why I'm suggesting probably not use less than 35 volts, because you do see a little bit of crossover on there, and without any adjustment you're stuck with it. So that's my recommendation. Use 35 volts and you will be fine. This is 8 ohm load, and we'll turn the gain up now until we hit clipping and then have a look at the meter. There we have clipping, and it's actually clipping slightly more at the bottom, so we'll take it back to there and have a look at the meter. We're on this scale here and it's as near as, damn it, 21 volts. Same thing again, but we now have 4 ohm load. I need to go back slightly so you can see it. There's clipping. Take it just out of clipping and look at the meter. Same scale again, this time it shows 19 volts. I thought we'd have a look at some square waves now, and this is our reference 1 kilohertz, 8 ohm load and about 5 watts output. As you can see, it's quite good. There's no overshoot or ringing on it. So let's go up in frequency. This is our 10 kilohertz square wave, and apologies for the mush showing on here. It is not from the amplifier, it's from something that's operating in the workshop. And I get this, and I've never ever managed to find out what it is, but it is not coming from the amplifier. This is 20 kilohertz, and as you can see, the speed of the amplifier is now beginning to show up, and it's actually a relatively poor square wave by modern standards. This is 100 hertz, and you can see it's not a terribly good square wave, and it's mainly because of the relatively poor low frequency response, which is probably caused by the input coupling capacitor being somewhat too low a value. These can possibly be modified, but I'm just showing you these tests out of the box. This is what you get. This is 10 Hertz, and obviously it's going to look miserable because the low frequency cutoff is quite severe. A little bit more information following those tests. DC offset on the sample that I have was 24 millivolts and quite stable. Not the best, but equally a respectable kind of number. That doesn't mean to say that all the samples will be the same, but I can only report on what I've got. As per usual, I've purchased this with my own money and I'm not being sponsored. I wasn't offered anything free and I have no allegiance to any supplier. But I have to say that there are many different retailers selling this board and the price varies almost daily. These actually came from AliExpress. I will put a link to show you where I actually purchased mine from, but I'm not endorsing or otherwise recommending this particular seller. He was just the one that came up, and with AliExpress there are so many offers. I bought this with 4 other items and I got free postage, whereas another supplier will have a lower price but you pay the postage. You know the story, it's very familiar. But don't just jump into the first supplier you find on AliExpress. Literally go through the dozens of them and find out which one is the best. I've only listened to this briefly because at the moment I've only got one of the 2 modules tested and working. The only listening tests I've done is with my stereo pair of speakers connected in parallel in mono, hence a 4 ohm load. What I can say about it is it's not the most detailed amplifier I've ever tested. Value for money or even Monday is tremendous. The components on it are, whilst the transistors are clearly second hand, but I would not regard that as an issue, the other components are basically bargain basement. The resistors are cheap but adequate. The capacitors are unbranded, well, unknown branded, shall we say. There's no Nichicons in this board anywhere near it. But saying that, there's only 2 or 3 capacitors anyway. It could be probably better if you care to replace the input capacitor, but there's no circuit diagrams with it. I know Ron has bought a couple of these boards and I'm sure I can report a bit later on what the distortion levels are. And in limited listening tests that I've done so far, it does lack a little bit of detail. But saying that, if you want it to just be a little monitor amp or something for the kids to play with, well, not to play with, but to use on a low-cost system, I would recommend it. I mean, you cannot beat that price. Do remember that it's not quite as low cost as you would first think, because first of all you need a heat sink. The one that I've shown you, wherever it is on the bench, just out of sight I think, that is more than big enough for both amplifiers to run it. It does get pretty toasty, but I've been sine waving and square wave testing it, so I think it's probably unlikely that you won't. So a smaller heat sink would be fine, but if you're going to run it into 4 ohms, it's a relatively powerful amplifier, 90 odd watts. Anyway, hope you've enjoyed this quick look at this little project. I've got some really good stuff coming up and I can't wait to get going because a parcel just arrived literally 15 minutes ago with some real nice stuff in it. So as they say, stay tuned, and thank you so much for watching. Leave a comment if you wish. I read all comments and will answer as many that I can.